Hi, this is Anthony Bedone for completeSql. Let's talk about Numa Nodes. More specifically, I want to talk about how to identify the Numa Nodes on your system. More specifically, again, there's hard Numa Nodes. If you're not aware of that, there's also soft Numa Nodes that we create from the hard Numa Nodes or just from the system itself. There's I/O completion ports that we have to be concerned about. There's lazy writer threads. There's CPU nodes as opposed to the memory node, the physical memory node. There's logical CPUs, there's physical CPUs, there's a resource monitor. So there's a lot of information, a lot of details related to Numa nodes. So I'm not going to talk about them specifically, but I want to show you how we can identify all those details on your system when you're working with your Numa nodes. So using completeSql, we'll proceed from there. And I have some code here that we can execute. So we'll get into the code and I'll go to the directory that I created called Numa Nodes and just bring up the code that's in there and actually execute all the code. Okay, so I'll select it and then just execute it. So now in the future, when I work with the Numa Nodes, I'll just execute this code and it'll put me in the right direction of what Numa Nodes are about. So we'll go into detail about each screen to help us clarify what Numa Nodes contain. So we'll go into the memory OS nodes and bring that up. Okay, there's a lot of information here, a lot of overwhelming information, and a lot of information that I just don't need for what I'm studying as far as the Numa node. So I'll go into my query code, go to scenarios, get a scenario, see if I can start narrowing it down for just my discussion. I'll go to include columns, get the include columns, and bring up that. Execute it again, and we did narrow it down. So now, just some background, the current system had, or actually has, two physical Numa nodes, two physical memory Numa nodes, and 24 logical CPUs. So from that, we had to carve out a design of hard Numa / soft Numa nodes. Okay, so having that, as you can see, I have node ID. So we carved out 8 logical CPU nodes, so 0 to 7, 8. So we have 8 CPU nodes. And of that, we have, as I mentioned, 2 memory nodes, so 0 and 1. And then there's groupings also we see. So as far as the 0 memory physical node, there's 4 CPU nodes, and here also 4. So this one memory node has also 4 CPU nodes. Another thing we see is the I/O completion worker address. So that was always a confusing thing, and actually in the documentation it's very confusing too. We see here now that the I/O completion worker address or the thread is actually tied to the CPU node. So when you create soft Numa nodes, which gives you the logical CPU nodes, you're also creating I/O completion ports, I/O completion threads, which help with your overall I/O as far as TDS transfers and network I/O. So it's very, very important, and it will help a lot too. So also, if we look over here, we have CPU affinity mask. So we know that there's a grouping of CPUs to each node ID, which is a CPU node. And again, we know that the CPU nodes are actually tied up to a memory node. So there's 2 memory nodes, and there's 4 CPU nodes per memory node. So a lot of information. But the key thing is here, I think, is that the I/O completion ports are related to the soft CPU Numa nodes that we created. Therefore, when you create soft Numa nodes, you'll get I/O completion ports. You can't change the memory nodes, but you can change the CPU nodes and therefore get I/O completion ports. So that's very important. The next thing we'll look at is the memory OS sysinfo. So I'll bring that up. It's already executed. A lot of information, probably too much information, so we'll narrow it down from the scenarios. Get a scenario. Okay, there's no scenario for that. We'll look at the include columns, get the include columns, and there is. Okay, execute it again, and we narrowed it down. So as I mentioned, there were 24 logical CPUs, and this clarifies and verifies that there are 24 CPUs, 24 CPU count, and the scheduler count is 24. So we also know that every logical CPU has a scheduler assigned to it. So 24 logical CPUs, 24 schedulers, so one-to-one relationship. So that was helpful too. And it also verified that we do have 24 CPUs, if that's a question in your mind. Next thing we can look at are the schedulers. So bring that up. Again, scheduler, this is just a select all from the scheduler DMV. A lot of great information, but too much, and I just want things that pertain to the Numa nodes in our study. So I'll go into the scenarios. I'll get a scenario. I'll bring that up. I'll go to include columns, get include column, and bring that up. Execute it again and just narrow it down. Beautiful. 24, I got 24 rows back, and we do have 24 CPUs. So if I look at the schedulers, I have 0 to 23. So therefore, there's 24 CPUs. Look at the CPU ID, there's 0 to 23, and we know there's 24, which is correct. 0 to 23 is 24. The information that I have here, I'll sort it again, sorry, is 0. As far as the node ID, we have 0, 1, 2, 3, 4, 5, 6, 7. So there's 8 parent nodes, which are the CPU nodes. As I mentioned before, we had determined that we do have 8 logical CPU nodes. Another great information we can determine from the screen is that there's 3 CPUs per CPU node. So as you can see here, the node 0 has 3, and the scheduler has 0, 1, 2, and the CPU is 3, 4, 5. Here we have the node is 1, 1, 1, of course, and we have the scheduler 3, 4, 5, and 0, 1, 2. So we do know now that the 24 CPUs are broken up in the groupings of 3 across each logical CPU node. Wonderful information there. Next thing is we'll look at the requests. This is very good too. Again, a lot of information from the requests, as you know, that's a great DMV, but too much here, and it just clouds our issue. So we'll narrow it down a bit if we can. So go to scenarios, and I have something here, and I'll bring that up, and I'll go to include columns, and I'll get the columns, and I'll bring that up. Execute it again. Comes back with eight rows. Okay, 10 rows. Actually, I'm sorry, this is 10 rows, but 8 resource monitors and 2 lazy writers. So that tells me a lot of information too. There's a lot of confusion about the lazy writer. There's 2 lazy writers, and we determined that we have 2 physical memory nodes. So now we know that the lazy writer is tied to the memory node. So you can create as many logical or soft Numa nodes as you want, but the lazy writer is only determined by the actual hardware of these memory nodes. So since we only had 2 memory Numa nodes, I only have 2 lazy writers. But another thing we see, I have 8 resource monitors. So the resource monitors are tied to the logical CPU nodes. We determined that we had 8 CPU nodes. I have 8 resource monitors. So that was just a quick overview of how you can determine what your system is comprised of as far as your hard, your soft Numa nodes, and all the related dependencies as far as lazy writers, as far as your resource monitors and so forth, and logical CPUs. So completeSql is a great tool to identify things and also to organize your code. So you create a directory, you drop the code in there, and it's always at your fingertips. So in the future, when you're working with Numa nodes, just bring it up, refresh your memory, move on, and change your system. And so that's it for completeSql, and I hope that it was helpful to you, and I hope you stick around for another showing at another time. Thank you very much, and have a good night.